Okay, let's discuss one more example. Uh, so what we have is a spool of thread, and there is thread wrapped around. Thread is the length of the thread is 10 meters. Maybe 10 meters is too much. Let's say it's 1 meters, and the radius of the spool is uh, 5 centimeters, and the mass of this spool is 100 grams. So the question is, if you hold the thread and let it go down, which means you let the thread go down, the spool go down somewhere here. Not a good handwriting, but let's assume that's how it's gone. This is 1 meter from the center to the top. Question is, what is going to be the velocity of the center of mass when it's going down? I mean, when it has already covered 1 meters. Okay, so how to solve this problem? Well, what do you think? Which principle can we use to solve this problem? Well, the one which comes to my mind is that we can use principle of law of conservation of energy. So this guy here actually fell from here to here. So it lost gravitational energy, but it gained kinetic energy. So the amount of gravitational energy it lost was mgh, where m is the mass of the spool, g is the gravity, and h is the height, 1 meter. We assume that there is no mass in the thread. And finally, um, the energy gained is kinetic energy. Right here is just kinetic energy. So it's going to be half mv squared. But is it just going to be half mv squared? Looks like we are forgetting something. How is this guy is different from a disk which is simply falling with a velocity v and there is no rotation? So this guy is rotating about the axis, but this guy is not rotating about the axis. So there must be a difference. The difference is that this guy also has a rotational kinetic energy. So we can write that as half I omega squared. And that gives us half mv squared plus half, we know that for um, a disk is mr squared over 2, where r is the radius of the disk, which we said is 5 centimeters, times, interestingly radius is not playing any role in here, but anyway, let's go ahead, and we know v equals r omega, so that gives us v over r squared. And if we solve this, we get half mv squared plus 3 over 4, excuse me, plus 1 over 4 mv squared, and that gives us 3 over 4 mv squared. So that, in fact, maths is also not playing any role, but anyway, I was a little careless in choosing the values. So that gives us 4 over 3 gh, and v comes out to be 4 over 3 gh.